Assalamualaikum. My name is Mehtab Mira. You are seeing Honey TV, and I've started newly a YouTube channel. You should subscribe this channel for more videos. Today we will discuss about waves. Let's start about waves. So we'll discuss about wave. The first question that rises when we are going to discuss about wave. What is wave? Wave is a disturbance. What is wave? Wave is a disturbance. There are two types of waves. How much type of waves? Two types of waves. One is transverse waves and the second is longitudinal waves. Types of waves. Number one, longitudinal wave, and number two is transverse wave. What is difference between longitudinal wave and transverse waves? Longitudinal wave is you can say, in which the motion of wave and the motion of particles is parallel. Means say the longitudinal wave include two things. One is compression and the second is rarefaction. This is called compression. Compression is in which the particles are closely packed and with great pressure. That is called compression. And the second, where the particles are separated, is called rarefaction. With the compression and rarefaction of the particles, the wave move and transmit energy or ATC. And now we'll discuss about transverse waves. Transverse wave is in this type. In transverse waves, the motion of particles is perpendicular to the motion of wave. Mean to say they both have 90 degree. Now we will discuss about the types of both the longitudinal and transverse waves. The type of longitudinal wave is sound wave. It's the most common example. Example of longitudinal wave is sound wave. Why the sound wave is longitudinal? Because it involves compression and rarefaction, and it cannot travel in vacuum. It can only travel in medium because it needs particles to travel. Second, we will discuss the example of transverse wave. All the waves that are in electromagnetic spectrum are all the longitudinal waves, which include X-rays, gamma, and many other like visible light. These all are transverse waves. Why these are transverse waves? Because they can travel in vacuum, because they do not require any particle. They travel with energy. So we will start about electromagnetic spectrum. The rays which are included in electromagnetic spectrums are radio waves, microwaves, infrared, visible light, ultrasound, ultraviolet, and X-rays, and at last gamma rays. The very simple way to learn these all is one sentence. Rugby match is very unlike xylophone game. I can also write rugby match is very unlike xylophone gain. From rugby, radio waves, match, microwaves is infrared, very visible light, unlike ultraviolet, xylophone, X-rays, gain, gamma rays. So now we'll discuss in detail how the wavelength, the frequency of these is differing as we move from up to down. First of all, we will discuss what is frequency. Frequency is the movement of part of wave from a fixed point in 1 second. You can say that, use a graph to represent the frequency. Mean to say this is 0, it's representing seconds. It's 1 second here. So the number of waves passing from a fixed point in 1 second is its frequency. Its frequency is 2, as the number of waves 1 and it's 2. You can find frequency using this formula. Frequency is equal to 1 over time. 1 means the number of waves. You can write here number of waves passing in 1 second as its frequency. Now we will deal with wavelength. What is wavelength? Wavelength is the distance from one trough to another trough. For example, this is the wave. The distance from this point to this point is its wavelength. Wavelength is a fixed point from one wave to another wave at the same point in its wavelength. You can say this is its wavelength, this is its wavelength, or if you draw a huge wave, you can say that this is its wavelength. So this was the wavelength frequency. What's the speed of the waves which are in electromagnetic spectrum? The speed is of light. The light speed is 3 multiplied by 10 power 8 meter per second. This is the speed of light. Same is the speed of radio, micro, infra, visible light, ultraviolet, X-rays and gamma. What's the formula to find the speed? Speed is equal to F lambda. F is here frequency and lambda is wavelength, and S you know is speed. Speed is equal to F lambda. If you want to find the frequency, just change the formula S over lambda, and if to find lambda mean to say wavelength, then the formula would be S over F, speed over frequency. These are the formulas you can use to find the speed, wavelength and frequency. Next, we will deal with how the radio to gamma, the wavelength frequency is changing. As we move from upward to downward, the wavelength is decreasing. Mean to say radio have highest wavelength, then shortest, and it's gonna decrease. The maximum wavelength of radio wave is about 1 kilometer. It can be more. It's about 1 kilometer wavelength of radio wave. So the wavelength decreases as we move down the electromagnetic spectrum. How the frequency changes? we can just use the formula, as the speed would all have speed same. So s is equal to f lambda. Speed is constant. You can use speed is constant. So f is equal to s over lambda. F is equal to s over lambda. As the speed is constant, so if the wavelength decreases, f would increase because they both are inversely proportional. F is inversely proportional to k over lambda. These both are inversely proportional. If wavelength is decreasing, frequency would increase. So the highest frequency is of gamma rays and the lowest frequency is of radio waves. Now we'll deal with the uses of all the electromagnetic waves. Radio waves is used in radios, most common use, and also used in televisions. And microwave is used in satellite communication, in telephones, and also in ovens. Remote control. In remotes, infrared is used, and visible light is used in optic fiber. Optic fiber is in which the net is coming to us. In it, plastic is used in which critical angle is made for traveling of messages or extra, and ultraviolet is used in sunbeds, and also in fluorescent tubes, and X-rays is used in medical imaging. This is the most important use of X-rays in electromagnetic spectrum. In medical imaging, X-rays are used. When you have any accident, your bone broke, you go to doctor and he use X-rays to take your images and detect whether your bone is fractured or what happened to it, is broken or not. And gamma rays is used in detecting the cracks. Detection of cracks in any pipe, in pipes, or the very tiny, like in gases. The gas tube is, if it is going, it have very minimum and very tiny holes from which it is leaking out. So gamma is used to detect those cracks. There are many other uses, but we can discuss basic ones. Now we'll have short summary what we have discussed today. First of all, we have discussed what is wave. Wave is a disturbance, as you know, and then we discuss types of waves. There are two types, as you know, transverse and longitudinal wave. These are the two types we discussed today, and their examples. Examples of types of waves, and then we discuss the uses of these waves, and at last we discuss what the relationship between speed and frequency and wavelength. Speed is directly proportional to frequency. Speed is also directly proportional to wavelength. We mean to say lambda. We say this symbol lambda, which means wavelength, and the relationship between frequency and wavelength is inversely proportional. We say speed is directly proportional to both f and lambda, and f is inversely proportional to lambda. These were the things we have discussed today. In next video, which will come sooner, we will discuss about visible light in detail. Be happy and live safe. Thanks for watching my video. Subscribe my channel and give good comments to my videos. Inshallah, we will come with a new and interesting video sooner. Thanks.